Welcome to the Profile Corner. I'm just in the process of creating some additional shafts for followers on the 3D Pantograph so that I can attach these follower heads onto the shafts. And I got to thinking, well, gee, I've got some fancy router bits here. Some of these would require a custom follower, like this one here also. This is a plunge roundover bit, and this one would be kind of neat to be able to use on the 3D Pantograph. However, I would need a custom follower that has that curved profile to it, and so we may have to see if we can come up with a way of creating one of those. I also have some other pointed bits in here that might be interesting to use on the 3D Pantograph. Here's a pointed bit that might be kind of interesting, and then under this cover there's also a very small pointed roundover bit similar to the bit that we used in the earlier video, but this one is even smaller. So after I get some of these shafts pounded into the follower heads that I've created so far, what we can do is we can actually take a look in FreeCAD to see how I actually created these follower heads and how you can use FreeCAD to create a model for a follower head for a bit that looks like this plunged roundover bit. So let me get a couple of these done here, and then we can go take a look in FreeCAD and see if we're able to create a couple of those follower heads. Now, I'm not using any kind of glue or anything like that. I'm just using a friction fit. And this roundover head is going to be a little bit challenging to pound in. It's a little bit hard to keep it from moving around. But these are just friction fit. Very tight tolerances. So that one is in. Now, the unfortunate thing is that I intended for this follower head to be printed in this direction here, but it couldn't actually be printed that way. And I did that by creating a small flat spot on the top. And of course, we've got a couple other followers here. This is just one for a straight bit. And that'll be easy to attach the shaft to, because it won't try to squirm around on me. Another one for a larger straight bit. There's a smaller metric size straight bit, and I can tell that because this is not beveled on the top, unlike some of these other ones that do have bevels on the top. And that indicates that I created it for a imperial measurement, so I don't have to measure it. I just know that that's for an imperial measurement. Okay, so let's go take a look in FreeCAD and see if we can't create some follower heads for some custom router bits like this one here. And then we can come back and see if we can put some of these to use to try to reproduce a 3D object. This is a FreeCAD document where I've created all the Pantograph followers so far. As you can see over here at the side, I can turn on one of the models so that it displays on the screen. And if I hold down the Alt key, I should be able to rotate this so that you can see that there's more detail there. Okay, so that's a pretty simple follower. There's also a 12mm follower, a 15, 22, and then these other followers down here are designed to duplicate an actual router bit. So the other ones up here are designed for following a template, and these would be used for following an actual 3D model using an actual router bit that's 1/2 the size of this follower. So that's a 1/2 inch follower. It's a 3/4 inch follower. So that would be for like a 3/8 inch wide bit. There's a 1-inch fowler, which would be for a 1/2 inch wide bit. The tapered fowler. So this would be for one of those bits that has maybe a 45-degree angle at the bottom. Cove fowler, which has got kind of a round over on the bottom. There's another cove fowler. This is for a 1/4 inch diameter cove bit. There's an 8mm fowler. This would be for fouling on a template. Same for the 6. And then the ones I worked on today are a pointed fowler. This one is probably not going to be a realistic router bit, because more than likely they wouldn't create a pointed bit that it has that sharp of a point to it. What I found is that oftentimes what router bit manufacturers will do is they'll flatten out this curve so it's not a true circle radius, instead it's an ellipse radius that the arc is created from. And so what I've done on this plunge round and over bit, which is one that we'll be looking at later on today, is I've actually created that using an ellipse arc for this section right here. Okay, so let's go about creating one of these fowlers. Let's just create a simple one. Okay, we've got to start out by creating a new body, which is a 3D model. So I just created that. And now if I click on it and then hit the F2 key, I can rename that. And this is just going to be a straight bit. So I'll name that. And now I've got to create a sketch in that body on the XY plane. And now for some reason on this computer it's not showing me where the origin is at. So I'm going to hold down the Shift key and I'm just going to pull down here, and it looks like the origin is up above there. I had created this project on a different computer and it looks like some of the controls are a little bit mixed up on it. But that's okay, we can work around that. Okay, so now what we need to do to start out is just to create a circle. And I'm going to create it starting in the origin, and then we can go out with it. And I want to create it at 1 inch, which would be 25.4. So there's the top view of the fowler. Now we can close this, and we're looking down on it. See if I can move the view down a little bit here. And now we've got to pad that to add a Z dimension to it. And we want to make it, let's say, 1 inch tall, so that's 25.4. Okay, and now we can rotate, and we can see there that now it has a height element to it. On the top surface, we've got to create a hole, and that hole is going to be used to insert the shaft. So I've got to start out and create a sketch. Okay, we're going to create another circle. Now my shafts were about 3/1000ths under 3/16 of an inch in diameter. And so that means that I need to create these at 4.6863 millimeters to match the shaft size. If your shaft size is exactly 3/16 of an inch, which is 0.1875 inches, then you can create your hole for the shaft at 4.7625. But I'm going to create mine at 4.6863 to match my shaft size. And now I can click on close because we're fully constrained. And then I can pocket that into the surface, and I should be able to go down 15 millimeters because we made this 25 millimeters tall, so that'll give me 10 millimeters at the bottom. I'll click on OK, and now I've got that set so that this is essentially done, except I want to make it a little easier to insert that shaft. So I'm going to click on the circle that's on the top, and then I'll add in a chamfer or a fillet. I'll probably put a chamfer on there, And let's say that that's going to be 1 millimeter, which is the default. And I'll click on OK. On my imperial followers, I like to add a little bit of a bevel on top here, just so that it's easy to identify that it's an imperial measurement. So I'll create a chamfer on top, and I'll set that to be 4 millimeters in size. Okay, so now that we've got that set, we should be able to rotate this and see the follower from all different sides. And so that one is officially done. And if we had another one that was like that, but a different dimension, different diameter, we could copy that by selecting it, going to the Edit menu, and then selecting Duplicate Selected Object. Now it asks us what we want to include, and we want to include everything, so just click on OK. And now we've got a duplicate down here. And I want to rename that one. And I'm going to call this one straight bit 0.75 inches. And now what I can do is I can go into that after I turn off the view of this other straight bit so that we don't get mixed up. We just have this one here. I want to make sure that that is the active body. So right click it, go up and select active body, and that'll allow me to do different operations on this particular model. So let's go into the original sketch that we created, and that circle right in there is 25.4 millimeters. We can make that 3/4 of an inch if we know what that is in metric. So that's 19.05 millimeters for 3/4 of an inch. Okay, we can close this sketch, and there's our modified follower. Okay, so that one is the one that's 3/4 of an inch. We can turn that one off and show the other one that we just created earlier. And to show that they're different sizes here, we can show one on top of the other. Okay, so let's create a more advanced follower, one that models the router bit that we looked at earlier. Okay, so I'm going to create another model, or a body, and I'm going to rename this one by clicking on body and pressing F2, and then I can give it a name. This is a plunge router bit. Okay, now I need to create a sketch on that body. And on this one, we need to use the XZ plane because we're going to do a revolution to create the 3D model from the sketch. And so we've got to create it on the XZ plane. And now what we need to do first is we need to look at this router bit, which had a 0.125 or an 1/8 inch flat spot on the bottom. And that is 3.17 millimeters in size. And so what I need to do is I need to draw in a line that is 3.17 millimeters long to represent a 1/4 inch. But we've got to double that because we've got a 2-to-1 reduction. So I'm going to start here in the center, and I'll go out, and I'm just going to click, and then we can fix that dimension later on, because sometimes when you're using this to create lines, it does weird things in terms of not always following what you want it to do. So we need this line to be 6.34 millimeters long. Okay, we need another line that's up above it to represent the side of the bit after the arc. And so we just come up and click. And now we need to set that one so that it's a certain height. Now I want to make this roughly an inch tall, so this will be 25.4 millimeters. And that inch tall makes it so that we're able to control the bit as it's coming down. Okay, now that's in the wrong spot, so I need to move this up. And we need that endpoint down here to be a certain distance off the axis. So we need to create a measurement here, coming down, and we're going to set that to be 7.62. This particular router bit has a width of its radius at 0.2 inches, and the height of the radius is 0.15 inches. And so we've got to duplicate that in FreeCAD, but we've got to double those measurements. And so that means that this measurement has to be 7.62 millimeters, which would mark the top point of the arc. And this point down here is going to mark the bottom point of the arc. Okay, now that we've got those two locked in, and we should probably lock in the distance from the vertical axis, which is Z, that needs to be 10.02 millimeters plus 6.34 millimeters, so that's 16.36 millimeters. So I'll click 16.36, enter, and now we've got the 2 points set for that arc. So now we can switch from creating a standard arc to creating an arc of an ellipse. I need to start out at the x-axis and click, go straight up, and click on the endpoint, come over to the other endpoint, and click, and then go back to the vertical endpoint and click again. And now it says that we've got a redundant constraint, number 13, that we've got to get rid of. Okay, so we'll click on that and hit the delete key. And now we've got this set. We still have two undefined constraints, but I think that this will actually work as it is. Okay, so we'll click on close to close the drawing. And there's the sketch so far. And now we've got to create another line that goes back over to the vertical axis and then comes down to the origin. So let's go back into that sketch just by double clicking it. And now we're going to need another line segment to go from this top point over to the vertical axis. And then we've got to go down to the origin. Okay, now we can click on close. Okay, so there's our sketch. Now we can create a revolution from that. So we'll click on revolution with the sketch highlighted. And there's the shape of our follower that we'll need for that router bit. All we've got to do is click on the OK button. And then what we can do is we can rotate to take a look at this follower. We need to get to the top view and create another sketch so that we can create a hole for the shaft to be inserted into. So we'll create a circle at the origin. And then we'll come out, and I need to make this 4.6863. And there's the shaft. Okay, so now we can click on close, and then we can pocket that, and we should be able to go in 15 millimeters again. Okay, so now that we've got that follower complete, we're ready to 3D print it after we export. So we need to select the object that we're going to export, which is the last operation in the object. You can go to the File menu, Export, and then we can give this a name. It's suggesting a name, but we also have to select STL for our file type. And this is going to be the plunge router bit, which is what it suggested for the name. And then we can click on Save. And then we can switch over to the Prusa Slicer and add that onto the Prusa Slicer's platform. Okay, we need to add in our object. So we can click on the Add button, select Object, and there it is right there. And we've got a problem that this will probably collapse because the bottom surface here is too small. And so we need to flip it 180 degrees on the Z-axis. So we click on it, and we should be able to just select down here 180 degrees, but I don't think that that's actually going to work because it looks like it's a little bit confused in terms of which is X, which is Y. There's the Y axis. It looks like it wants us to rotate it 180 degrees that way. So we'll type in 180, hit enter, and now it's upside down. I'm not sure why our axis got mixed up when it got imported in, but the Z-axis should have been up and down. Okay, so now that's been rotated, and now it's ready to print. Here's the 3D fouler for the plunge roundover bit. As you can see there, it matches up pretty closely with the original. I also printed out a fouler for a pointed roundover bit, which is what we used in the router the last time to create various objects on the 3D Pantograph. So what I think that I'll try to do is to use a rounded tipped bit that you can see right here to try to reproduce this shape, the top surface of it. This is a block plane that I had sharpened a few weeks ago, and I'll be using as a fouler this rounded fouler, which should match the profile pretty closely. So I'll get that mounted into the 3D Pantograph, and then we'll get started. Now I have 1-inch thick stock mounted here on the table. I have a secondary camera set up so that we may be able to see the cutting action a little bit better. I have that round nose bit installed into the router, and it's set so that when this template fouler is touching the top surface, it should be cutting into the top of this board by maybe 1/16 of an inch. Okay, I think we're ready to get started. let's take a look at it. It's an interesting little thing. I suppose it reproduces it. I'll have to bandsaw that out and see how it looks. It needs to be sanded down a little bit, but it turned out pretty neat. I've sanded it a bit over at the oscillating spindle sander. Now I just need to shave off a little bit off the bottom here. Okay, so there's our plane that was created on the 3D Pantograph. That's a pretty neat ability that this thing has to create 3D objects that are half size of the original. Now, the black plane may not have been the best choice to use as a model, but it looks like it worked out pretty well. It's going to need a little bit more sanding to make it look nice, but I think it's going to work out real well. Here's the plane with an oil wax finish on it. I think it looks pretty nice. Hey, that's all for today. Thanks for watching. Bye.